LED glow with 2 resistor series connection. To do, note the LED glow. Note the LED intensity decrease due to increase in resistance in series. LED glow 2 resistor parallel connection. To do, note the LED glow. Note the LED intensity increase due to parallel connection that increase current to LED. Outcome of the LED glow exercise. Learn how to connect components in breadboard. Learn how resistance affects current flow in LED. Learn series connection and parallel connection and the LED intensity change. Capacitor 1 resistor. To do, press the push button for 1 second and leave it to off. Note the LED glow. Note the LED remains on for some time even after push button is off. Capacitor with 2 resistor series connection. Press the push button for 1 second and leave to off. Note the LED glow intensity comparing previous exercise. Note the LED remains on more than the previous exercise time even after pushing it to off. This is due to increased resistance that increased current flow to LED. Outcome of the capacitor exercise. Learn how to connect components in breadboard. Learn how capacitor stores charges. Learn how resistance impacts LED on time. Some reference videos on YouTube are shown below with the links. Diode LED on. To do, note the LED on and analyze the reason. This is due to diode negative, that is the side with white band is connected to negative of the battery or power adapter, and diode positive is connected to positive side of the battery or power adapter. Diode LED off. To do, note the LED off and analyze the reason. This is due to the diode negative, that is the side with white band is connected to positive of the battery or power adapter, and diode positive to negative power. Outcome of the diode exercise. Learn how to connect components in breadboard. Learn how diode behaves by experiencing one direction current flow and other direction current blockage. For reference, some YouTube video links are given in the notes. Transistor LED glow. To do, press the push button on. Note the LED on when push button is on and vice versa. Note the resistance is 100 kilo ohms. So very small current is given to transistor and it switches on LED, which gets power from battery. When transistor is on, it acts as a short circuit. Outcome of transistor exercise. Learn how to connect components in breadboard. Learn how transistor switches on for small current to its base terminal, thus acting as amplifier. Learn transistor behavior that acts as short circuit when turned on, thus acting as a switch. For reference, some links are given in the notes. Building blocks of a computer. Let's make kids understand the similarity between computer, robots and human. Ask on the components of computer and purpose of each. They have to come up with something like mouse and keyboard for input, monitor and printer for output, and then finally CPU for processing. Let's stimulate them further by relating a computer to human. Let the kids come out with sensory organs, say ears, eyes, nose, tongue, touch, which are 5 sensory organs, then about the processing unit, which is brain, and output are expressions, kinetic movement, speech, etc. Next, relate the same with robots and say camera is eye of a robot, and in the same way for each sense there are various types of input devices called sensors, and the output devices of robots are basically motors or LCD display. Processing unit is microcontroller that is made up of crores of transistors, which we studied previously. These are some classification of input and output devices of a computer. As shown in this figure, you see that the whole unit is separated into 3 types: input, process and unit. When the switch is pressed, the signal goes to microcontroller in process unit, and the processor triggers the output unit to run the motor. This is the basic principle to build a robot. we need to design an input unit, process unit, and output unit, which we will cover in the upcoming slides. Let's ask this question to kids. How computers understand us and sends a reply to us? When we type a letter A in keyboard, how computer gets it as A? Does computer really know English? With that question in mind, we shall have an activity. Marching orders programming languages. Marching orders activity is mainly focusing on how important is the language and the sequence of instructions when it comes to communication. So if something is not conveyed properly, then things will mess up not only in life but also with robots. The activity goes like a kid from group will be called and given the activity sheet that will have some pictures in it. Let's target one picture per child and let's fix the rules as follows. Every kid will have a paper and pencil except the kid who has the picture sheet. The kid with picture should explain verbally about its characteristics without asking any question or getting feedback from the audience kids. They have to just draw whatever they hear. Let's take turns and swap the kids between audience kids. Finally, discuss on the results that explains the importance of language. Computers can understand only 1 and 0 and nothing else. But what really is 1 and 0? It is just on and off respectively, but what does that really mean? Let's see in the next slide. Humans have to communicate with computers. How do humans understand this on and off? Here, kids should understand that similar to how humans communicate with fellow human using some language, the same way computers have language named binary language. Like how English language are made out of 326 alphabets, the binary language, which has only 2 bits, 1 and 0, are on and off for human understanding respectively. 1 means some voltage and 0 means no voltage. Count the dots, binary numbers. Data in computers are stored and transmitted as a series of zeros and ones. How can we represent words and numbers using just 2 symbols? As a part of this activity, each student will be given a poster as shown below. Note the other side of the poster is blank. One side is having dots. The number of dots represent the count that each student should shout out to audience. Audience will ask a number between 0 to 31 and the students holding the poster should flip according to the number requested. Initially, for ease of learning, let the kids do just by counting the dots and let the count be sequential from 0 to 31. Next, let's make the 5 kids understand the pattern. Kid with 1 dot poster should flip every count, then kid with 2 dots poster for every multiples of 2, then kid with 4 dots for every multiples of 4, and kid with 16 dots for every multiples of 16, and so on. In this way, all 5 kids with poster will find the activity easy. Then make it tricky, ask for random numbers between 0 to 31. Now it will be difficult as the conversion is little difficult. Next, let the kids note down the pattern for each count on paper. The side with dots should be considered as 1 and the side without dots as 0. The result will be a 5-bit table as shown. Make them understand that the same way keyboard converts the keys pressed into binary and sends to the computer processor. The activity tells only about numbers, but what about alphabets and words? So for that, there is a standard called ASCII, which is American Standard Code for Information Interchange, that has a binary sequence for every alphabet, symbols and numbers. To understand how to convert a number to computer understandable form, it needs some knowledge on importance of encoding and decoding, which is as follows. Encoding is nothing but convert understandable form to non-understandable form. Decoding is nothing but convert non-understandable form to understandable form. Let us consider an example for encoding and decoding. So let's decode with the keys shown below. So for pencil, book, eraser, bag and shoes, the numbers are 1, 2, 3, 4, 5 respectively. So pencil plus book will now give a result of 3 because the value for pencil is 1 and for book is 2. In the same way, the subtraction between shoes and eraser will give us value of 2. So from this example, kids should be clear on how encoding and decoding works. Bridging the digital divide. Decimal is nothing but human understandable numbers, that is 0 to 9, whereas binary is computer understandable, which is 1 and 0. So in order to communicate with any digital device, this conversion happens again and again, and the cycle shown, which is from binary to decimal and from decimal to binary, is a routine process. But how does computer know to convert it? Binary to decimal conversion method is shown here. The direction flows from right to left, that adds up 2 to the powers of x with multiplied binary digit, where x corresponds to the place value. Added result corresponds to the decimal digit. To convert decimal to binary, divide the decimal number by 2 every time till it becomes less than 2. Mark the remainder every time it is divided. It will be either 1 or 0. Then from bottom to up, need to arrange the numbers that corresponds to the binary number for any random decimal number. Give more exercises to convert between binary to decimal and decimal to binary.